the screen is visible to everyone. We'll just start the session. Okay, so in today's session, we'll be going to the detail of how you can assemble and fly a drone yourself. Okay, so we'll be going towards the practical part in today's lecture. In the last lecture, we discussed that it would be better to go into the further detail of how these things are actually built. So in this session, we are going from the circuit to the sky. That means the actual fly of the drone. So let's dive into it. So this is the content of today's session. So first we'll be looking at the quadcopter components and the UAV components that are involved, which includes the motors, the propellers, the body itself, and a lot of details. Then we'll be going ahead and look into these flight controllers, which are basically the brain of the unmanned systems. And then we'll see how these flight controllers are used with external accessories and what kind of accessories are necessary and what add-ons you can always put to these drones and perform various kinds of tasks. And then we'll see how these GUIs are assembled and how these things are patched together. And once the hardware assembly is done, we'll go ahead and look how the software part plays an essential role in controlling and navigating all of these drones and stuff like that. And then ultimately, we'll go ahead and see how we can use the remote controllers to control these drones to navigate as per our requirement. And in the end, after all of this sequence of building the stuff, we'll have a look at the final test flight that you would expect in the outcome. Okay, so well, let's start. So there are various different kinds of UAV systems that are out there. And today we will be looking at this specific configuration, which is the quadcopter or basically the multi-rotors. So the process, the procedure is almost similar to all unmanned systems in which there is no pilot involved. And we'll see how many different configurations can follow the same process or the similar process that we'll be looking at today. So we'll start with example of this quadcopter. The name quadcopter suggests that it has quad means 4 propellers. So yeah, it's a multi-rotor system in which there are no wings involved. Okay. So if we talk about the basic components that are to be used in a quadcopter system, well, okay, so we have a drone's body. Okay, here we have something called an ESC. ESC is an electronic speed controller. What it does is that it controls the speeds of these BLDC motors. Okay, so these UAV systems, the drones, they use a specialized motor, which is the brushless DC motor, brushless direct current motor, the BLDC motors. So these BLDC motors are used for drones because they run super fast. Normal DC motors are not that fast. Their RPM is quite comparatively low. So to control the speed of these motors, we are using a specialized motor driver that is this ESC, electronic speed controller. So the way it works is that we give a PWM signal from a microcontroller and it adjusts the output voltage that is given to these motors. So if we are giving more voltage to the motor, it will run faster. If we are reducing the amount of voltage, it will run comparatively slower. So it's the job of the flight controller to give the required PWM signal to this ESC electronic speed controller so that the RPM is adjusted as per our requirement. Then we have the body frame of the UAV system itself. Normally, this is made from carbon fiber because weight is the biggest concern in designing the body of any aerial vehicle. So it should be strong and it should be lightweight. So carbon fiber plays the best role here because it satisfies these constraints that it should be stronger but lightweight as well. So different kind of materials are also used rather than carbon fibers, whatever is suitable as per the requirement. Then we have the heart and the brain of the UAV system. Okay, so that is the flight controller. Okay, so all algorithm, all the theory of unmanned systems, everything that you may study in some subject, it is converted to coding form, the programming language, and it is ultimately fed to this flight controller. Everything runs here. So this is basically the brain of the whole system. Every command comes from this point, from this flight controller, and every decision is made in this flight controller. Okay, then we have these BLDC motors, which are the brushless DC motors. They are super fast. There are different kinds of BLDC motors out there. Everyone has its own specs. Some are heavier, some are used for lifting heavier payloads, some are used for about maneuvering the drone a bit fast in comparison to the others. Well, different configurations exist for these BLDC motors. And then we have propellers that are attached to, of course, these BLDC motors. These are also made from carbon fiber or other plastic materials as well. It depends the quality that you are working with for your drone. And then we have this camera. This camera could have different functionalities. It could be used for surveillances. It could be an AI-based drone that uses this camera to perform certain tasks. Like if some of the students remember from the last class that we saw that how these cameras were used to, well, pick apples from a garden using the UAV drones. So these cameras can be used for AI based, artificial intelligence based applications. So we have a gimbal attached to this camera because the drone will be maneuvering left or right around, and uh, the camera will oscillate in accordance with the drone. So we have this gimbal that, well, stabilizes the camera so the video is not shaking because of the maneuverability of the drone. And then we have the batteries. The drones use specialized batteries. These are the LiPo batteries, lithium source battery. And we do not use normal batteries for drones because, well, they consume a lot of current, a lot of current. Like 40, 50, 60 amperes of current is just the normal case scenario for a little small drone as well. Well, not that small, but a laboratory sized drone easily consumes a lot of amps. So these LiPo batteries have the capability that they can provide you a certain high discharge of current. Okay, so we cannot use a lead acid battery or simple lithium ion batteries or anything else because we need a huge amount of current, a certain high discharge of current in a very small amount of time for the drone to perform the maneuvers that it should. So LiPo batteries do the job. Then we have specialized battery chargers that are used to charge individual cells in these LiPo batteries with the feedback, because these are very, very dangerous as well. If any of the battery, well, if it is punctured somehow, or if you give the incorrect voltage levels to the battery, well, they blast and catch fire. Okay, so these are dangerous batteries. You should always work with them, considering the safety precautions. A lot of precautions. These are dangerous batteries. I've seen some of them explode right in front of me. So lipo batteries, because of this lithium, which acts with water and air, it catches fire. So any contact with the air, well, there is the explosion there. So then we have a receiver and a transmitter. This is used for the communication from the ground where the user is standing who's flying the drone. The transmitter is at the ground and the receiver section. The receiver section is mounted on the drone itself. So we are using this radio frequency independent communication channels. We could use always another other kinds of channels as well, like satellite communication and other types. Well, usually this radio frequency communication is used to communicate with the drone for like manual piloting of the drone. So, for example, if you want to make the drone go left, right, forward, backward, up, down, you give the commands from this transmitter, and they are received from this receiver that is mounted onto the drone, and the drone in accordance with the signals from the ground, well, performs those actions. So then we have antennas for longer range because yeah, drones are bound to move away from the user. So it depends on the range of the antennas, how long, how far away that you can well, fly your drone. So basically, these are some of the basic components. There are a lot of individual details and extra accessories that are involved with the UAV system. So, but we are not looking at right now. We are not looking at all of those details. But these are some of the basic components that are involved in a quadcopter system specifically, right? So, well, in this whole component list, this flight controller, which is marked over here. So this flight controller is basically the brain and the most important part in this whole system. If the brain is not working right, it doesn't matter what kind of body you had made, how good it was, it's not going to work, it's not going to perform the things that it should. Okay, so this flight controller is one of the most important components. We'll go ahead and look into the detail of how these flight controllers look like, how do they work, what do they have to do, what is their job, and stuff like that. So flight controllers. So basically, these are the controllers where all of those control engineering stuff and the aeronautical engineering stuff and all those theories that state how UAV systems fly, what should be done, what should be the decisions, all those techniques, everything is converted to program, and that program is uploaded onto some hardware platform, and that hardware platform is the flight controller. So this is an off-the-shelf available, easily available in the market flight controller that is named this Pig's Hawk. It is the most widely used system for basic UAV systems that you can just build and play with, or you can use it for some basic applications, maybe not of product level, but yeah, for basic applications, you can go ahead and use these flight controllers. So this Pig's Hawk is basically an electronic circuit based hardware prototype that has the necessary sensors, the electronic equipment, the voltage regulators, or the microprocessor. Basically, they use the STM32 microprocessor series and a lot of basic details. So there are different versions. This is the most cheapest version. There's an advanced version. This is a Pixox 6C. It is comparatively a bit expensive, but it has more redundancies in it, and it is a bit more reliable in comparison to the basic version. It does the same job. The concept is same, but in this case, it is more reliable to work with. And then we have the most expensive one at the moment, which is this Pixel Cube. It is really, really good. The job is again the same. It has even more redundancies. One sensor fails, the other comes to the play. If that fails, the third one comes to the play. So the probability of the flight controller failing during the flight is very low using this Pixel Cube Orange. Okay, so there are different kinds of flight controllers hardware structures available, which are at the moment blank. You have to upload the program into these physical systems, and then they will be ready to do something. Okay, so by default, they are just electronic circuits that have nothing in them. So there are some other cheap choices as well. For example, here we have something that at STM32 F7 series. It is called the F7 flight controller. It looks something like this. It's just the basic, just the basic necessary electronics, and it is smaller in size for small UAV systems and a lot of cheaper, but again a bit less reliable than the above controllers. But again, the trade-off is with the cost. And here we attach all of these extra components, the motors and everything using the wires. But in in the Pixoc case, we attach them using plug and play connector systems. So again, there are various kinds of flight controllers available in the market. All of these are electronic circuits with all those necessary electronics mounted onto them by default. There's no need to develop these things from scratch on your own, because you can't compete with the industry which is already working for years on these hardware systems. So these are quite cheap as well. It's not worth the effort to like design these things on your own. So we will be going ahead and looking on to the components that will be attached to this flight controller and how are they attached. Okay, so we'll take this Pixhawk cube at the moment because it is the best one. So let's go ahead and see. So here is the Pixhawk cube flight controller, and all possible all possible components that could be attached to it are displayed in this picture. Okay, so we'll start bit by bit and see what are the things that are attached to it. Okay, so we have four motors. This is the first motor, this is the second motor, this is the third motor, and this is the fourth motor. And we understood that every motor had an electronic speed controller, the ESC, right? That is used to control the speed of these motors. So these black ones are the electronic speed controllers. So each motor has the individual electronic speed controller. Okay, so four motors, two here and two here, along with their four electronic speed controllers, are all connected to this small power distribution board and are connected directly to the Pixhawk. Okay, so we have four motors connected to the Pixhawk directly. Okay, then we have a power module that is attached between the Pixhawk and the battery. Okay, so we are not connecting the battery directly with the Pixhawk, but there is an power module involved in between. The job of this power module is to keep a check on the voltage and the current of the battery. That way we understand, okay, the battery is low, the drone should land, or otherwise it will just fall out of the sky because the battery is low. What can you do about it? So if you do not put a voltage measurement and a current measurement sensor in that flight controller, you will never know if the battery, what is the status of the battery. So we have this power module that is used to measure the statistics of the battery at the that you are using. And then we have something called an IR sensor, which is not a necessary thing, but it could be used. This is used for well, nearby obstacle avoidance and distance measurement applications. For example, you could use this sensor for detecting any obstacle nearby for autonomous flights. If your drone was flying and you found a building, a chair or table or anything nearby, so this IR sensor would detect, okay, there is something nearby, and gives a signal to the flight controller. And then the flight controller can make a decision that the drone should stop, otherwise it will hit it. Otherwise, you would never know. So basically, these are kind of like the eyes of the drones that you may or may not want to use. Okay. So then we have these LiDAR sensors. These are basically, again, can be used for detecting distances with a lot bigger range than IR sensors. They're also used for 3D mapping applications as well, and indoor navigation. They can be used to, well, map the indoor environment around the drone so it can work indoors as well with a stable flight. It will not, well, it will understand its current position. It's a bit technical, the use. So if anyone is interested, we can discuss more about this LiDAR sensor. Okay. So then we have this component which is also directly connected to the Pixhawk. This is called the telemetry. So this module is basically used to transmit the data from the drone to the ground station, so that you understand, okay, my drone is at this height, so the voltage, the current, and the signals and everything at the drone side is being communicated to the ground station via this telemetry. So this is basically the link. It sends the statistics of the drone to the ground station. Okay, then we have these GPS modules. Okay, so this black circle and this one, they both are GPS uh, GPS modules that are also attached directly to the Pixog. Two are added, only one is needed, but two are added for higher accuracy. If one fails or one is not catching the signals from the satellites, the other one might play a better role. So we have two GPS signals. Their job is to communicate with the satellite, and so that if you are out of range from the ground station from where you were in the first place controlling the drone, it can communicate with the satellite and give coordinates to the drone, and the drone can autonomously go to some points. So this is kind of like the most important part for any drone mission, because yes, definitely the drone will be ultimately out of sight, because that's their purpose. Out of range, I apologize, not out of sight, out of range after a certain distance, and then these GPS play the role. Okay, so they are communicating with the satellite, which has a much bigger range, and they get their position and everything from the satellite, and that position is used for the autonomous navigation of the drone itself. Then we have these servo motors, which are used, which can or cannot be used in a drone. So these are basically used for, well, maybe dropping some payload or picking something up, or any moment attached to the drone. Okay. For example, you could well, use the servo motors to deliver a pizza. You can attach a pizza to the drone. It will go from a certain distance to another point, and then you will just turn the servo motor, and the pizza will drop from the drone, and you can turn it back and go on. So these can be used for applying different actions using the drones. Then we have these optical flow power, the optical flow modules, and these are used for measuring the position indoors, and well, because GPS signals are lost if you are deep inside some concrete structure. So it's difficult to fly a drone inside a building because the GPS signals are quite weak comparatively. And then we use techniques like this optical flow along with the LiDAR sensor to map the indoor environment, and use uh, these sensors to judge the position of the drone, and the position is required for every action, every navigating action. Okay. Then we have this small buzzer, which is just for indicating stuff like warnings and other stuff like that. And then we have this USB part as well, which is for programming, uploading the code and stuff like that. And then we have these two chip antennas along with this receiver, RC receiver. So this is the main thing here, which will be transmitting the video. A camera is attached to this receiver as well. So this is a well, this will be used to transmit the video from the drone to the ground station, and to receive signals from the ground station to the drone. And uh, there's FHSS involved as well in this specific module, frequency hopping spectrum, that avoids the jamming of the signal. So basically, this is used for the wireless communication between the ground station and the drone itself. And then we have this remote controller that is in the hands of the user, which is the ground station. So something like this is used to navigate the drone from left to right or here and there. So basically, this is the basic structure and the basic, some of the basic components that are involved and can be connected directly to this flight controller. And yeah, so this is basically the hardware part of the drone structure. So now we will look how these things can be assembled. So we purchase some frame like this from the market. It's very cheap comparatively. We get a battery. It can be placed at the bottom or at the top or anywhere that you find it suitable for. So we have some basic structure of a quadcopter system. And then we have this plate, which is also in this package whenever you buy it. So it has some electrical components which can be used to, well, connect all those motors in together along with the rest of the stuff. So this is basically the BLDC motor, and this is the electronic speed controller. So electronic speed controller has 3 wires. The BLDC motor has 3 wires. They are all plugged together and they work together. Okay, so this goes to the battery itself. There are a lot of different videos available on the internet about the assembly process of the drones. So you can always go ahead and explore more. So this is just basic. So this is the electronic speed controller, which is used to control the speed of this BLDC motor. So these wires are connected to each other. You are using these bullet connectors because you can always will always want to change the motor as per your requirement. So you put these connectors so that you can connect and disconnect whenever you want. So it will look something like this. You attach these motors with some screws, you attach the propellers, you attach the electronic speed controllers, and you plug all of these together. So there are small holes at the bottom of these motors, and you plug them onto this frame, and all motors are connected. You put the electronic speed controllers along with all these motors, and you so just solder them together, connect them using some connectors. Okay, so I'll just maybe move this video a little faster. Sorry about this. Just a second, please. I'll just. Okay, so I just want to. We can just look at here offline. So that's pretty much it about well, yeah. So I have another detailed video of the assembly process. So for example, if you were to purchase some frame of the drone from AliExpress, Alibaba, or any or Amazon or anywhere, so you get this kit. You choose the instruction, see the instruction manual, and you start the assembly process. You plug everything together. You tied all those screws and the details. So you put the motors together. Here the electronic speed controllers look different. So they are like this, the black one, the ready to sky company. So you plug everything together on these arms of the this is a hexacopter system. Hexa stand for the 6 arms. So from the internet you see, okay, this is my motor 1, this should be my motor 2, 3, 4, and 5 and 6, and the blue ones are rotating anti-clockwise and the green ones were rotating clockwise because that's the concept. So it's an open source software and information available on the internet. You can always search and see the detail of which motor is motor 1, which is 2. So this is basically the receiver that will be communicating with the ground station, and this is the flight controller, the PIGZOG that we just saw in detail. So this is the basic PIGZOG, not the cube orange, because normally you always start with the cheapest one, the basic for your practicing stuff. So you connect all the connections of all those motors. This is the buzzer with this flight controller, the PIGZOG, and this is the power switch, safety switch button. You connect everything with this PIGZOG. As you see, this is quite simple, just plug and play of equipment. So that was the GPS that was being attached to the system. You connect every electronic component, the necessary components uh, to this PIGZOG flight controller, and those lidar sensors, IR sensors, they were not necessary. Then you connect this telemetry that has a USB with it to your laptop or to your PC, and you can get data from the drone to your PC. So this is the software, one of the softwares that can be used to program, to control, to upload the coding process. It is very straightforward, very simple. You can use it for different configurations. You can choose it for different flight modes. That, for example, you push the first button, it will start to fly. You push the second button, it will land. You will push the third button, it will do this and that. So you can program all these details. So this is the flight mode one, which is the stable mode, and you can choose different. We'll just see about that detail as well. So this is the remote controller that you use. So you set your channels. This is a lot of technical, more detail involved here. I'm just giving you the basic overview. We'll go to the question answer session in detail if anyone has any confusion in this process. So I'm just giving you the basic idea that this is an open source software available. This is the Mission Planner software, and it has everything that you would ever need to do very different kinds of functions using a drone. Okay, so you are uh, using different channels and assigning every channel a specific task. You configure different parameters and you set everything together and ultimately connect the battery and the drone is ready for flight. So this is basically the hardware stuff. You plug everything together, you connect everything together, and then you open the software and you start integrating it with the hardware. So this is the software. This is just a basic screenshot. So I'll just go ahead and open this software and share it with you because it was not suitable to put all these screenshots when I could have arranged this software. I hope the screen is visible. Yeah. So yes. Yeah. So this is basically the software. It has a lot of detail. So you what you do is when you connect your GPS here at the moment, it says there's no GPS here. Okay. At the moment, it says there's no GPS. So once you have connected it with the hardware, you can just directly get the location. You can just directly get the location that your drone is at, and you can get it in real time at any place in the world. Okay. For example, you will just see that your drone is flying right now at this point. Okay, so here you get the live statistics. You see the battery voltage here. Here you can on your own observe as well what is the state of the battery as well, and how much current is being charged, what is the altitude of the drone, what is the ground speed, what is the yaw angle, what is the vertical speed. Here there is a lot of detail and a lot of individual statistics that are you can observe. So we have this setup and we can install these firmwares onto this flight controller. Basically, these are the firmwares that you can use for free. These are all open source. So using this Pixhawk flight controller, what you can build is you can build a quadcopter system that has these 4 propellers. You can build a hexacopter system that has these 6 propellers. Okay, you can build an octocopter system that have that looks like a quadcopter but has 2 propellers at each point. So there are 2 propellers at this point, 2 propellers here, two here, two here. So in total, 4 motors and 4 propellers. You can build a helicopter using this flight controller. It is available open source, free for everyone. You can build a tricopter, you can build a hexacopter in a tricopter configuration, or you could use individual 8 propellers octocopter that has 8 propellers. You can also build this rover car using this Pixhawk flight controller, and you can use it for antenna tracking system as well. So basically, these are some of the basic UAV unmanned systems that this mission planner, the Autopilot company, offers the rest of the world. This is all open source and easily accessible for everyone. There's a lot of extra detail involved in this software. You learn it with respect to time. So you can once you have set everything together, uh, you can plan your flight paths uh, by using this plan tab. You can just say, okay, I will start from here, then I'll go from this point to this mountain over this road and do this and finally I'll do that. You can plan everything here. You just upload this button, right? Okay, and the drone will autonomously take off. You don't have to you don't have to give manual commands during the mission. It will autonomously follow the exact path and perform the actions that you described in this tab. Okay, so here you can use this plan tab for the detail mission. And then we have other details of all those extra accessories that I showed you that could be used. And then a lot of different applications that are not useful at this stage. Okay, so this is the basic structure of this mission planner software. Okay, so coming back. So similarly, like this mission planner, there are a lot of other softwares available as well. For example, this Q ground control, QGC, it is the normal one. So it looks something like this. I'm not opening the software right now, but it offers a lot of extra details that Mission Planner does not. For example, you can fly a generic flying wing configuration using QGC. Okay, Mission Planner does not support this, and again, another open source easily available to public. This software you can use this software to fly this wing shaped drone. Okay, so all you have to do is get the body, plug and play everything, get the motors, plug everything together, and open the software and just upload the program. So everything is by default fixed. So the new things here are these wing drones. For example, this is another different wing configuration drone as well. And we have a hybrid VTOL system as well, which is a quadcopter along with wings. Okay, and then we have tricopters and again bicopter with wings and a different configuration of VTOL and again a tricopter type VTOL system. So there are a lot of different configurations, and this is really in detailed software. So QGC is more advanced, but maybe mission planner is for the beginners. Once you start, a lot of stuff can be done using the mission planner, but once you are comfortable with flying the basic stuff, you can always go ahead and explore this Q ground control. So like I showed you that there are PIXOGs and there was this F7, the smaller electronic looking like thing like flight controller. Well, it uses this another software called the Beta Flight. So this is for those F7 or F4 controllers that we saw other than the PIXOG that we initially saw. Let me go back and show it to you again. So yeah, so I'm talking about this one. So there's a PIXOG series, and then we have this F7 series. There are a lot of other series as well. So the fly controllers looking like this. They are specifically for quadcopters and few more configurations. They do not offer very versatile operations. So this beta flight is used for these. They are this beta flight is normally used for racing drones where you want all flexibility. You do not want any constraints. So this is again somewhat less developed than the mission planner or the QGC, the autopilot, but it is again a very popular choice among the users. So any racing drone that you might have seen around, so they are probably designed using this beta flight software. Then we have this iNav software as well. This is used for this has more detail than beta flight. You can put more constraints. This is good with GPS configurations as well, autonomous flight, and a lot of other details can be used in this iNav. So if you want your drone to use those F7 controllers and you don't want it to used for racing, you want to put safety constraints and you want to control a lot of detail of the drone that you are building, you can always go ahead and use this iNav software. Okay, again, this is the remote controller that one of the example of the remote controller that we normally use to fly the drone. So it has two joysticks. One is this red one. The second one is this red. So moving this joystick forward will make the drone fly upward. Uh, Getting this stick backward will descend the drone, and moving it to the left will rotate the drone anti-clockwise. Moving this stick to the right will rotate the drone clockwise. Moving this stick forward will make the drone go forward. Moving it backward will bring the drone backward. Moving this stick to the left side will make the drone go left, and moving it right will make it go to the right. Then we have these switches using this toggle switch. So these switches can be used to perform to assign different functions that you might want your drone to perform. For example, you just flick this switch downwards and your drone will land, or maybe you flick this switch downward or upward, your drone will flip, or your drone will make a circle, or it will just take off from one point and go to another point and land, or perform an autonomous mission that you pre-planned using that plan tab in the mission manager that I showed you. And maybe you you flick this button downwards and it will drop the pizza, and you well plug it to the forward direction or to the other direction. It will just grab some stuff and move on. So these switches, these are the channels basically. They can be used to perform different kind of functions that you might want to use using drone. Maybe you have put some agriculture spray onto the drone. You flick one of the switch and it starts spraying the crops, and then you flick it upwards and it will stop the spray. So are different kinds of actions that could be performed using these drones can be assigned to these switches. Okay, so basically these two joysticks are for the navigation part, and the rest of the details are for performing the extra actions using those drones. So this is the flight control, the remote controller that the user has in his hand, and that's pretty much it about the basic introduction to the DIY do-it-yourself drone making process. And then I found this good video from the YouTube, and this is a very good representation of what you would expect in the end once you have done everything. So this person is controlling, has the same flight controller here and giving commands hands, and the drone is moving around in accordance with the commands coming from this. So it is using the fixed of flight controller along with the battery and the rest of the detail that we saw today. And the command is being sent here and receiver is attached here and in accordance with the command. So he is not giving the commands anymore, and the drone is positioned again at the point that it was. So again, he's just moving it around. So this is something that you would expect in the end after following all that process, using this open source software, plugging everything together. At least you will be able to fly the drone, and then you can go ahead and make a drone and again do the performance or use it for the application that you wanted. Okay, so that's pretty much it about the drone making process and the expected outcome that you would expect in the end. So that's pretty much it about this session. Thank you, everyone. And we can go ahead and have this question answer session. Thank you.
Thank you, Abdullah. Yes, as he said, if anyone has a question, you can use the hand reaction or leave a comment in the chat. So we have a question from Ismail. Let's see what he has to say.
I'm sorry for taking time. Yeah. Good morning, sir. Good morning, everyone. Yeah. Thank you for the presentation. Yeah. This is my question. How could do-it-yourself drone technologies contribute to achieving the United Nations Sustainable Development Goals? particularly in agriculture, health, or climate action?
Yeah. Okay, so it would entirely depend on the application that you have built your UAV system or the drone for. Okay, so if the application is satisfying or it is under the umbrella of any of the SDGs, then yeah, you are contributing to the SDGs. Otherwise, you just made it for fun. For example, maybe you are using it for spraying some good stuff on the crops. Then yeah, you are you're going to that economic growth and sustainability development goal. It totally depends on the application that you would be using it for. Okay, because the drone itself has no specific application. It could be used for a lot of different variety. So whatever the application that you are using, that application has to be under the umbrella of SDGs.
Thank you, sir. I'm grateful.
Okay.
We have another question. Let's see what they have to say.
Yeah, hello, Abdullah. Good afternoon,
Right.
everybody. Yeah, my question is, I would love to know these drones, is there a way these drones can be attached with a self charger, one that could gain current, maybe from the rotation of the propellers, and then a router is put to it where it can automatically charge the batteries while in flight, so that if it's going to take a longer flight period, if you observe as the controller of the drone that the battery is draining, you needn't bring it back to base to charge the batteries. While in flight, as the propellers are working, it could be automatically charging the batteries, getting the current as attached to the propellers. That's my question. Is there a way such could be added to that device? Thank you.
That's a very, very good and interesting question. Well, the process that we studied today, it's not possible using that process. The way it works is this. Uh, you have a propeller, maybe a wind turbine or anything, a propeller attached to a motor, and you are not giving any current to the motor. So if the propeller rotates, okay, so if the propeller rotates, that means the motor is rotating. So there is copper winding attached to the motor, and the external part of the motor is has some magnets. So there's a magnetic field, and copper is a metal. So magnetic field has some metal inside it, and there's a law called the Faraday law. Faraday law states that uh, if you rotate if you rotate a metal inside a magnetic field, or if a changing magnetic field acts on a metal, an EMF is induced in it. Okay, so it is possible to generate electricity using the motors of the drone, but then you can't use battery. You can't do it both ways. So maybe you have the drone in your hand, and you're not using battery to rotate its propeller. The propellers are stationary. The wind or some other phenomena is being used to rotate those propellers, and an electricity will be generated which can be used to charge the battery. But if your battery is being used to rotate the propellers in the first place, then your current is already going in one direction. The propellers are already being rotated using the electricity, so they cannot generate electricity in this case, because they are already consuming the electricity for the movement. If the movement is somehow by some other means other than the electricity, for example wind energy, then you can generate the electricity. So it's not possible in this scenario. Maybe you
So
could
in,
put, like, in the case of electric cars, and or the even engine cars, you could use some steam engine. You could use some steam engine for rotating some motors, and the drone is in the air, and then you can put some extra propeller that is not being used during the flight, and because of the flow of the air, it will rotate and it will generate electricity. It will act as a wind turbine. then that electricity could be used to power to recharge the battery for a longer duration. But it will not be a very suitable choice, because if you put a small wind turbine on the drone, it will add more weight. So if more weight is added, more battery will have to be used to take it off the ground. Okay. So you wanted to create more energy, but to create more energy, you already used more energy. So you have to think about a balance in between. Okay. So
Okay.
during the flight, it is not possible to create electricity while using it, and you cannot take the drone off without using the electricity.